Are you building a generative AI-powered application? If you are, then you probably already know how using the right vector database is critical when it comes to unlocking highly relevant results for retrieval-augmented generation. You probably also know how performing vector search at scale can be extremely compute-intensive. But what if I told you there's a way to achieve the same awesome results at scale with an out-of-the-box solution that won't tax your CPU? As creators of the world's most deployed vector database, we here at Elastic have extensive insights into some of the challenges associated with putting vector databases to work at scale. And without a doubt, the biggest challenges are getting started and getting it to perform at scale. That's why today, I'm excited to share how scalar quantization is a game changer when it comes to delivering relevant results, both from your initial experimentations to when you start shipping and growing. Before talking about that, let me first explain. Vectors are multidimensional numerical representations of words, images, or sounds that capture the semantic essence of the original object. There could be hundreds or thousands of dimensions per object being stored, causing vectors to be huge, as in humongous. Instead of just trimming down the number of dimensions per stored object, scalar quantization is an algorithm that compresses the space needed to store each of these dimensions, effectively shrinking a vector's overall size without materially impacting your ability to use it towards surfacing highly relevant results. But why should you care? You should care about scalar quantization because when you're building a generative AI-powered application, using vector search to provide context to an LLM is amazing until the compute cycles required to perform vector similarity searches at scale exceed the limitations of your infrastructure or your wallet. In other words, you should care a lot about the efficiency of your vector database, especially with respect to its ability to search and store vectors. At Elastic, we make scalar quantization easy by integrating it directly into Elasticsearch. And while our default settings help to ensure optimal performance and best-in-class accuracy, we also provide you with the ability to customize as needed. This enables you to bring your generative AI applications to market quickly without losing the option to customize and tune your application in the future. Now let me give you a real-world example of scalar quantization in action. Models are in general lazy. With the default values returned by embedding models, each dimension has the possibility of 2+ billion values. But the model really only uses a tiny subset of that on output, so we quantize to simplify. Here's how. Take a vector, normalize it with the calculated quantiles, and you have a reduced memory footprint, minimal accuracy loss, and faster search. With Lucine's architecture, we can update the quantization as and when new data comes in. At the end of the day, scalar quantization isn't rocket science, but it is a great example of how Elastic is committed to building the world's best vector database so you can bring high-performance generative AI applications to market faster.